I am Chandra Jagan Mohan. We will discuss about the electrical power generation. So, the electrical power generation is needed today very much for different requirements such as domestic, industrial, agriculture, commercial, all these things. So, in the electrical power generation, we are having different sources. So, mainly in our traditional methods of producing the electrical power generation, the hydroelectric power, the generation of the power with the help of the hydropower. So we are using the water. So we are getting the power from the hydro. That's why we are calling it as the hydro power generation. Okay. So for generating the hydropower, we need certain things. Okay. We need a catchment area. We need a head. We need a construction of the dam. Okay. We need the availability of the water. All these things we need. So first, for generating the power from the water, so generally we can generate a small amounts of power from small rivers, streams, canals. So, but this power will not guarantee the hydropower supply throughout the year. So for this purpose, we are going to construct the dams. Again, in the dams, we can divide it into low power generating dams, medium dams, and high level dams. So if you are constructing a dam, we can guarantee the hydropower supply throughout the year. In fact, the hydropower supply will be guaranteed with the help of the dam like a battery. Okay, we are able to store the water. We will be having the reservoirs. So there are different types of dams, like cascaded dams, okay, runoff rivers, runoff dams, all these things. So first thing, whenever we are constructing a dam, we are constructing the dam for multi-purpose. So the water which we are storing in the dam helps us for controlling the floods and for controlling the famine. Okay, if the water is excess, it is stored in the dam. If the water is less, we can release the water from the dam for the irrigation purpose, for the drinking purpose, for the industrial purpose, and for the generation of the power. So our discussion is about the hydropower plant. So we are calling it as hydropower generation because with the help of the water, which we can call it as the hydro. So we named it as the hydropower. This power is hydropower. Since the power we are taking from the hydro, okay, we are calling it as the hydro power plant. So you can observe the dam. So there will be a forebay, there will be a tail race, okay, there will be penstock. All these things will be there in the dam. So the construction of the dam assures the supply of the power throughout the year, at least for some amount of power during summer season also. And we are able to reserve the water for the summer season, and we are able to control the floods in the rainy season. Okay. So in the world, nearly 16% of the power generated is because of this hydropower. So there will be the head in the dam because of the construction of the dam. This head is very important. So from this head, the water will flow to the turbine, and because of that force the kinetic energy of that water. The turbine is going to rotate, and this mechanical energy is converted into electrical energy with the help of the generators. After generating, we will step up this generated power with the help of the step up transformers, and we will transmit this high voltage power to the cities, to the villages, to the industries, all these things. There we are going to step down the power. So this is the basic thing which is going to happen in the hydro power plants. And next, so as I told earlier, this dam will act as the battery. We can store the water, and we can release that water whenever it is needed. Okay. Even though we can generate a small amount of power with the help of small rivers, streams, and canals, the reliable supply will be with the dams. The reliable supply will be with the help of the dams. Okay. So the dam creates the head. Okay. From the head or height, the water will flow to the turbine with the help of the pipe, the help of the pipe called penstock, the help of the pipe called penstock, and through this penstock, this water reaches to the turbine. So whenever this water is going to reach the turbine and create the pressure on the wings of the turbine is going to rotate. There are different types of turbines based on the requirement, based on the head, all these things. Okay. These turbine blades, whenever this turbine blade is experiences the pressure of the water, it is going to rotate. So whenever the turbine is going to rotate, this turbine is coupled with the shaft of the generator, and the generator is going to rotate. So after this, the electricity is produced, and this is stepped up, and afterwards we are going to transmit this power with the help of the transmission lines. Afterwards, we are going to step down this high voltage power according to the requirements with the help of the step down transformers. All the help of the step down transformers. A hydropower plant basically consists of different main parts like the head and the intake, a forebay. So a forebay is the place where we can store the water before it is going to the intake. So whenever it is needed, we can supply it to the intake. And penstock. So from the head to the turbine, the water is carried to the turbine with the help of the penstock. Below the turbine, there will be the draft tube. Afterwards, there will be a tail race. Okay, and the turbine is linked with the generator, and this is placed at the generator house, powerhouse. From that, we'll use the transformer to step up, and we'll supply it to the transmission lines. So the main parts of the hydroelectric power plant are the dam area, forebay, intake structure, penstock, surge tank, and the hydraulic turbines, maybe impulse turbine or reaction turbine, Kaplan turbine, Francis turbine, the powerhouse, the draft tube, and the tail race, and the spillways. Okay. These are the different things which are present in the electrical power, hydroelectric power plant. So if you see the dam, so dam is the thing which is constructed across the flow of the river. So to construct a dam, there should be a availability of water and availability of high head, and the area which is favorable for constructing the dam. Okay, this dam basically stops the flow of water, and it will store the water. So we can control this flow of water with the help of the dam. After stopping, after storing the water with the help of the dam, we will divert this water to the turbine in order to generate the power. So during the rainy season, we are able to store the water, sufficient water. We will be having a sufficient water during the rainy season, and we will store, and parallel we will be generating the power there, and we can generate this power throughout the year by storing the water. And also the main thing is we can able to control the floods with the help of these dams, and we can increase the irrigation with the help of the dams. The dam should be able to withstand the pressure of the water. It should be able to withstand the pressure of the water, and it should be watertight. It should be watertight. The dams, basically there will be three types: arc dams, gravity dams, and buttress dams. The head of water in the dam is called as the head race. It's called as the head race. Next we will see what is the forebay. What is the forebay? A forebay is the area where the water is stored before it is going to the intake chamber. So here the water is stored temporarily. According to the necessity, we'll release this water to the intake according to the demand, according to the load requirement. We can release this water. So after this forebay, the water is going to the intake, and from that intake, it flows through the penstock and it reaches to the turbine. The intake structure. So the main purpose of this intake structure is to store the water, is to collect the water, as much of water, and store it for throughout the year. So from the forebay, the water comes to the intake. So there are different types of intake structures according to the local situations. So here in the intake there will be a trash rack, so which diverts the debris, so which will not allow this wastage and the fishes into the penstocks. So afterwards, the after the intake, it enters into the penstock. This is about the intake. The penstock is a pipe-like structure which carries the water from the intake, from the water when it is coming from the forebay to the intake, to the head, from the head to the turbine, from the head to the turbine. This allows the water to flow through it. It directs the water to the turbine. So, and the other main thing is the surge tank. So this surge tank will help to decrease the pressure developed in the penstock, and whenever the water is less, whenever the pressure is more in the penstock, it is going to store in the surge tank, and whenever suddenly the water comes, this is going to store in the tank, and whenever there is less water, it is going to release that water as required. The hydraulic turbines, there are different types of turbines. These turbines rotate, and because of this rotation, these are linked with the generators, and the generator is able to produce the power. The power is able to produce in the powerhouse, and we are going to supply it. So in these turbines, there are majorly two types, that is impulse turbine and reaction turbine. Okay. The example for the impulse turbine is Pelton wheel, and for the reaction turbine is the Kaplan turbine and Francis turbine. Turbine will be having a tail race and after bay. So this is about the hydroelectric power plants. The major things here are the dam, the forebay, the intake, the penstock, the surge tank, and the hydraulic turbines, and the powerhouse, and the draft tube, and the tail race, and the spillways. So basically, we are going to construct the dam for stopping the flow of the water, and that is the catchment area, where there will be head, there will be a intake structure. So before this intake structure, we will be having the forebay. So from this acts as a reservoir. From the forebay, it is going to come to the head or the intake structure. From that intake structure, it is going to the penstock. From that penstock, it is going to the turbine. The turbine is going to rotate. After the turbine is connected to the generator that will be in the powerhouse, and afterwards there will be the draft tube. There will be a tail race. There will be a tail race. So the surge tank, the purpose of the surge tank, whenever the water, excess of water is going to come, it is going to store that excess of water, and whenever there is less water there, it is going to release that excess of water, and there is a stability in the flow of the water. Stability in the flow of the water.
Like, share and subscribe. Hit the bell icon for more updates.